this is our CPT1200DCAI series power supply. This is a astronomical input. That's what the AI stands for. The astronomical meaning it uses an astronomical clock and a GPS antenna to determine where it is in the world. And it's going to automatically update every single day what the dusk to dawn time is. So this power supply knows what the sun is doing. So it's a truly set and forget system. The first thing you have to do, however, is allow this power supply to pick up on that GPS pass and give it the ability to program itself. And all you have to do that is plug it in. You're gonna see a red LED flashing with EEE. Oh, and there you go. Once it turns green, that means the power supply is programmed. Now you have two primary functions for this power supply. On the bottom right of this switch, you have run auto. That's your automatic dusk to dawn setting. So you can set it onto that. And it's gonna tell you here in hours, how long it's gonna take until the lights turn on. Now they don't use a timer because that's gonna mess up daylight savings. You don't have to make a daylight savings adjustment. This goes off of the sun. It doesn't matter what your watch is saying. So 7 hours from now, it's gonna turn the lights on. And if you come and check the clock or this power supply later while the lights are on, it's gonna have a countdown timer for when the lights are gonna turn off. So that's your automated feature. We could just set this and walk away. As you can see, it updated to the minutes. So now 6 hours and 59 minutes until this power supply turns on. So after your power supply is picked up its GPS, it is already programmed to operate on the run auto if that's a feature you so choose to use. The run manual, this is just your integration feature, so you can tie in via dry contacts on both circuits your security equipment. So think of motion sensors, web relays, really anything that offers a normally open or normally closed signal. Anything that fires that signal, this power supply can receive it. There's also a power supply failure where this will fire a signal in the event that the primary power goes out. So we really have thought of just about everything for the security integrator to make this as high of a level of security power supply as you want it to be for your security posture. Now, whether you're gonna operate this power supply on run auto or run manual, it's very likely you're gonna need to check the system during the daytime. So how do you manually turn the power supply on? Well, first off, put power to the circuit. So circuit 1, circuit 2. For this power supply or this system, we're only doing about 30 luminaires and we only need one circuit, one 600 watt circuit. So we're gonna turn circuit 1 on. And now you can do this on either run auto or run manual. If you take a little jumper cable, all you have to do is touch the voltage plus or the common tap in the manual on, and this light will turn blue, meaning your system is on. You also have to remember after you do all your checks and tests to turn it back off. Now the system's on and we can do our voltage checks. The first one we're gonna do is right here at the power supply. And we're gonna measure the total load this power supply is using. We do this by taking our multimeter and first confirming the DC voltage. This is important because most multimeters, especially the value ones, don't read DC current, they only read AC current. So you need to change it to DC. This is a DC power supply. You can just stick it right on these and you should be reading 32.4 over 30 volts DC. So 32.4 volts, we're gonna write that down. All right, so next thing we're gonna do is just check our current. So move our meter back to DC. Sometimes you'll get a ghost reading on these without anything on it. And we are pulling 8.5 amps DC. So now we have all the calculations we need to determine the total load on this power supply. It's important to ensure that your system is operating under safe load conditions. Okay, so we measured 32.4 volts DC. You multiply this by the amps, so 8.5 amps DC, and this is the total load. This is the total power being consumed by our system. Power consumed is measured in watts. Power provided is volt amps, although it's the same calculation. Volts times amps equals watts. 275.4 watts is what we just measured this system as pulling. Now each one of these circuits is 600 volt amps. Now the safe operating load of any power supply, low voltage especially, is 85% of its total capacity. So a safe load is anything below 510 volt amps. So we are well below safe load for this system. And this is over a 500 linear foot system, and we're not even using a quarter of what this power supply can provide safely.